Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, we are going to work on the parabola. Now, this is actually our second lesson in our chapter of analytic geometry, also known as conic sections. And what I'm going to do is work through my notes, just like I was teaching inside of the classroom. So in this lesson, what you're going to learn is how to determine the vertex, the focus, and the directrix of a parabola, as well as how to write the equation given the vertex, formula, focus, and directrix. Now, I know I kind of threw out some new vocabulary, which we will go ahead and discuss later in this lesson, but what I wanted to kind of start off this lesson with was just some problems that hopefully you've experienced with the parabola in previous lessons, either in your study of quadratics or of polynomials, because students are at least most familiar, I would say, with the parabola out of all of our conic sections. So the way I started the lesson was giving the students a problem where if I gave you the vertex and then I gave you a point that the parabola goes through, see if you could write the equation in standard form. So remember, the two forms that we have used most often for a parabola or quadratics has been your standard form as well as your vertex form. Now, we've done different things for different forms, right? But the one important point was the vertex form was obviously with the name of the vertex, meaning that H and K represent your vertex. So I don't really have a way to represent my H and K in this standard form, the way that it's written. So therefore, I'm going to, even though the problem is saying find the answer in standard form, I'm going to use vertex form because I'm given the vertex. So what I'm going to do is I'm just going to kind of label the points that I have here. You can see I have 1, 3 represents my vertex, so therefore I'm going to represent that as HK. And then I have a point that the parabola runs through. And again, remember, any coordinate point can be -1, 1. So in this point, I have an equation, right? And if you kind of count the number of unknowns, you have 1, 2, 3, 4, 5. So we have 5 unknowns. We have Y, A, X, H, and K, right? But again, look at the information we have. We have 4 givens. So then what I'm going to do is just going to plug in my X, my Y, my H, and my K into my form. And you can see that's going to allow us to solve for A. And if you recall, A in the standard form and the vertex form, that is going to be like, that's going to help us determine how if the quadratic is going to be opening up or opening down, as well as the vertical stretch and compression. But either way, I'll just plug in those values and go ahead and simplify. I get A equals -1/2. So now I can write the formula in vertex form, right? So I can just plug in -1/2 in for A, and then just plug in my H and my K. However, the question was saying find this in standard form. So what I'm going to need to do then is expand this, and notice this binomial squared. When I expand that out, gives me a perfect square trinomial. I distributed the -1/2, and then the only thing that was kind of a little tricky here was to add a -1/2 plus 3, but you can see I kind of did this work as a little sidebar over here. Just to remind you, you can write 3 as a 6/2, and then you can combine them, and that's how we got to 5/2. Now on to some definitions. So the vertical parabola, basically the quadratic that we're most familiar with, also can take on a new standard form, which is in the form of x minus h squared equals 4p times y minus k. Now this p is something that we talked about last section. We didn't really discuss what it meant, but basically what we did is we just kind of described it as like, oh, here's this new variable or this new number that we are going, or this new variable, this new value that we are going to be incorporating. So it's very much related to these. I'm not going to get through these relationships here, but you can definitely go ahead and just rewrite this and solve for y. And therefore you can see how that 4p is related with your traditional A from these two equations. I'm not going to get into that for this lesson because my point that I want to go with the students is, remember H and K, that's going to represent the vertex, something we are familiar with. So what P represents is our focal length. And basically the focal length is going to be the distance that our parabola or our vertex is from our focus. Now I used to do, and actually when I used to teach this in Algebra 2, we'd actually do a lot of lessons where we would investigate this length. And it actually is a pretty nice lesson. I think it's really interesting for students to be able to see how that works and how to see how this value P comes together. But the general idea here is if we have a parabola, let's just draw a parabola like this. So here's going to be your vertex. This is going to be your focus. And that distance from our vertex to our focus is going to be our focal length, which in this case is going to be P. Now, the interesting thing that happens here is we also have this line, which we call the directrix. So the directrix is going to be P, but it's going to be in the opposite direction. So don't think it's always negative P. Just think of this as, again, P in the opposite direction. Okay, so therefore we can go P is always the distance from the vertex to the focus, which sometimes is a positive direction, sometimes it's a negative direction. But then opposite of P is going to be from your vertex to your directrix. And actually, I'll just use this. So that's going to be my focus, and that's going to be my vertex. So obviously, guys, we can have a parabola that opens up, right? We are familiar with that, and that would be when P is positive. However, if P is negative, then we're going to have a parabola that's going to open down. So I'll kind of draw something like that. It's going to basically kind of take this same shape, you know, and again, we don't have to have the vertex on the origin. It can be kind of moved over. But the main important thing that I want you to kind of see here is, you know, let's say here's the vertex now. Let's say here's the focus. So now in this case, if we have the focus now below the vertex, what's going to be happening here is just P is going to be now negative. It's going to be in that negative direction. But again, P is still just going to be that distance that's going to represent from the vertex to the focus. And the opposite of P is going to be going to your directrix. So I don't want to write, you know, in this case, you can see that P is going to be, I guess we can just write it in there. From this case, it's going to be a negative P, or at least it's in that opposite direction. And then from there to there is going to be P. Now, let me actually just go ahead and fix that, because it really is still going to be P. Actually, I'll just kind of write that distance is still P. It's just going to now be P in the opposite direction. And this is going to be a opposite of P. So opposite of P. Okay, now again, P could be positive or negative, which we'll kind of talk about there. The main important thing I just want you to see is where it's going up or down. And actually, you know what? Let's just change that up. I know I'm kind of starting to get a little confusing here. But now in this case, we can say P is going to be negative, and that's going to be a positive P in that way. But again, the difference here is you can see that we have a parabola that's either going to open up or open down. The other thing I just want you to kind of recognize here is that the directrix is a line. Okay, it's the same distance away from the vertex as the focus is. And then also that it's perpendicular to the line of symmetry, or the axis of symmetry, right? So if I have my axis of symmetry, you can see my directrix is going to be perpendicular. Now, one of the things I am going to kind of skip over for those of you, as far as like the definition of a parabola, as far as like the set of points that the equal distance, that is one thing I kind of like bring up to students. That's the cool thing about the parabola. If you kind of look at this directrix here and you kind of do something, that the distance here between your focus and your directrix to any point is always going to be equal. So that's kind of like where we come up with that definition of the parabola. But again, a little sidebar, we're not going to get into it, or at least kind of further do that discovery. But that is one thing I like to show students, why we have this focus and the directrix, like what are their importance. Again, another thing, if you look at, if you're looking at like sun rays or, bifocals, every single time when you have something in, it's always going to direct back into that focus. So there's a lot of applications with this as far as the focus and this parabola. But in this lesson, we're just going to kind of focus on identifying these certain parts. But obviously, if I was in the classroom, I would spend a little bit more time kind of talking and like showing students how this kind of works for different, shapes of parabolas, for like eyeglassware or satellite dishes and all that kind of stuff. Seeing why that focus, how that is in that importance from there, flashlights or like lights, seeing how everything rays out. So it's, definitely some pretty interesting stuff and also some applications. The one thing I want you to see is when we have a vertical parabola, that my focus now is going to be up and down, right? So we find the vertex and then you're just adding P to be your focus. Now again, P could be negative or positive, right? If P is positive, it's going up. If P is negative though, it's going to go down, but you're just adding it. Now, to find the directrix, you're just going to subtract P. So again, it doesn't matter if P is positive or negative, because if you subtract a positive, that's going down. But if you subtract a negative, that's actually going to be moving it up, okay? and then P is going to represent the focal length. Now, the important thing here is we need to recognize we can have parabolas that are vertical. Obviously, those are quadratics. We're used to those, right? But we can also have a parabola that is going to be horizontal. So if x was squared, we knew that was a vertical parabola. But now, if y is going to be squared, that means our parabola is going to open up to the left or to the right. Now, just like if a parabola opens up, that means P is positive. Well, if it opens up to the right, that means P is going to be positive. For a vertical parabola, if P was negative, that means it opens down. Well, if P is negative for a horizontal parabola, it's going to open up to the left. Just kind of think of like the XY axis, you know, up is positive, down is negative. Well, same thing, Y is positive. Going to the right is positive, going to the left is going to be negative. But the same idea, you can see there's really no difference in the equations that we're using. P is still representing the focal length. It's still the distance from my vertex to my focus. And then we're going to subtract that value of P to go to the directrix. The only difference is, again, now we're dealing with parabolas that have horizontal openings instead of vertical openings. So let's go and take a look at what that would look like in terms of a parabola here. So that's going to be kind of going. So if I'm going to have this parabola, let's here open up to the right. All right. Now, again, my focus here is going to be to the right. And again, this distance here is going to be P, whereas the opposite distance here is going to take me to my directrix. Now, again, remember the directrix. One thing I kind of forgot to mention here, notice that the directrix is not a point. That is one of the, misconceptions a lot of students will make. They'll treat the focus as a point, the vertex as a point, but the directrix is not a point. The directrix is a horizontal line. And if something is a horizontal line, then it needs to be in the form of y equals, not x equals. So that was my mistake right there. I do apologize for that. I'll have to go ahead and change my notes. In the same respect, over here, you can see that this needs to be a vertical line. So this needs to be x equals. So I didn't kind of cover that or check myself on that. But you can see that x is going to equal h minus p. But that is a vertical line. It's not a coordinate point. So it's a very big distinction that we need to make sure that we are doing here. So now we're going to have p. And then again, that's going to be our negative p. That's our focus. And this is going to be our directrix. Now, in addition to that, we have our vertex right there. We could also do another parabola where it's going to have a opening now to the left. And that's going to look the exact same. It's just that now the distance from my vertex to my focus is going to be negative p. So let's go and put our focus here. Let's put this to be our vertex. So we'll just say that's going to be negative p. That's going to be my vertex. And then p is now in the positive direction is going to take me to my directrix. Okay. So that's going to be dealing with, we have a horizontal parabola. And again, really the main difference is, recognize what we're doing with the focus to go from the vertex to the focus. You can see we're adding P to the X coordinates, right? And to find the directrix, we're subtracting P to the X coordinate H of the vertex. But just make sure you understand my correction here, that the directrix is a vertical line. So therefore it's going to be X equals. And for the vertical parabola, it's going to be a horizontal line. So it needs to be Y equals. So make sure you have on those corrections. So now let's get into the examples that I kind of covered into the class. So this is what I would have covered exactly for my students, was just a simple all right, here's, an equation, find the vertex, the focus, and the directrix of a parabola. Now, typically, when we're first kind of doing this, I have students just write it out, for all your values. Use your parentheses, put it exactly into the form that you're familiar with. So you don't technically need to do this, but it is one of those things I just like to show students my work and my thinking process, so therefore they can kind of see how I'm getting my answers. So in this case, I have x minus 1 quantity squared equals negative y. And all I did is I just rewrote this right-hand side as negative 1 times y minus 0. So it's just a little bit cleaner approach for me to be able to kind of see it now in this format. And again, to really all I need to identify my vertex, my focus, and my directrix, I need to know my h and my k, as well as I need to know my p, okay? So in this case, I can see my h is 1, my k is going to be 0, and then my P is going to be, well, 4P is equal to -1, so therefore P equals a -1/4. Now, one of the misconceptions a lot of students will do is they'll want to go ahead and use these formulas, right? And you can definitely use the formulas. I just think your students, a lot of times they kind of forget, am I adding, subtracting, and like am I adding to the positive, am I adding to the negative, like to the X or the Y? And they just get confused and they get it mixed up. So what I recommend the students to do is, you see that the X is squared. So therefore, it's going to be opening up left or right, right? So what I'm going to do is I'm going to plot the vertex. And then, so once I plot the vertex, then I'm going to say, all right, P is negative. So that means, remember, if you think of P as that distance from the vertex to the focus, that means I have to go down -1. And notice that the parabola always opens up towards the focus, right? And again, the directrix is going to be perpendicular to that axis of symmetry. So if I have my vertex as 1, 0, then if I have the focus is down -1/4, yeah, you could do 0 minus 1/4, but you don't really need to show the work. Hopefully you just recognize it's still going to be over 1, but it's just going to be down -1/4. And then remember, the directrix is going to be minus P. Well, since P is negative, you're subtracting a negative P, so that's actually going to give us a positive 1/4. And you can see that Y equals 1/4. You can see how that's going to create that equation of the line. So I typically like to just look at this graphically, but I do understand that some students just like to remember like the kind of rules like adding, subtracting to which coordinates. I just think it's very easy to get those kind of confused if you're not looking at, where these values are. Now in this next example, this one's kind of confusing because in all of our standard forms, the whatever quadratic we had here, this binomial squared did not have any coefficients in front of it, right? There's no coefficients in front of there. So what should we do? Well, we should get rid of that coefficient. So what I'm going to do, first step, is divide by 4 on both sides. Now I have it in this more form that I'm a little bit more familiar with. Now I can identify my H is -1, my K is -1, and my 4P is equal to 4. Therefore, divide by 4 on both sides, I can see P is equal to 1. Now again, I know that Y is squared, right? So therefore, I know it's going to be opening left or right. And since my P is positive, I know my focus is going to be going to the right. So therefore, if you kind of look at this equation, you can say, all right, here's the vertex. My focus, though, is going to be to the right of that, right? And so if I take this vertex, which is at what, -1, 0, and I move that to the right, that's going to give me a new point of, that's wrong, -1, -1. That's going to give me a new point of actually, and I can see this, I switch those around. To the right is going to be 0, -1, right? Because, and again, you can look at that, like I graphed it correctly, I just wrote down the answer incorrectly. So that's why I like looking at this graphical approach, because I was able to quickly audit my answer and say, oops, I did something wrong. But again, like here's the point. If you're going to move this 1 unit to the right, you're going to add a 1 to the X coordinate, right? You don't add a 1 to the Y coordinate. That doesn't make any sense. Adding a 1 to the Y coordinate is going to shift it up. We're trying to go to the right of the vertex. And then remember, to find the directrix, we're going to take our X coordinate and we're going to subtract 1. So therefore, you can see that's why that's at -2. But remember, it's a line, and a vertical line is going to be in the form of X equals -2. All right, so that was all the problems that we have. And then typically what I would have done in the classroom is I would have said, all right, guys, now it's your turn to go ahead and to do these problems. And my students at this point would be going up to the board or working with them in their groups, and then go ahead and presenting their answers. Now, since I kind of spent some time, at least in depth, going through these answers, I'm just going to kind of work through these a little bit quicker, and just at least not go through as much in depth as far as my explanations here. So, but I would just say the first thing, guys, is just to identify the vertex. So in this case, the vertex, or the H and the K, right, is going to be 0, 0. And then we can say that 4P is equal to 8, right? Because that's the coefficient of the Y. So I'll divide by 4 on both sides, and I can say P is equal to 2. Now again, I recognize this to be an X squared. So therefore, if I have my vertex here, right? So I'll just plot the vertex at 0, 0. I see that it's X squared, so I know it's going to open up or down. And since P is going to be up 2, or positive 2, I know it's going to be going up 2. So really, just from this information here, I can just go ahead and plot it and say, all right, the vertex, I'll just rewrite the information. The vertex is 0, 0. The focus is going to be 0, 2, right? Because I need to move up 2 units from my focus, from my vertex. And my directrix is going to be down 2. But just remember, guys, it's a horizontal line. So we write a horizontal line as y equals -2. And again, you could follow the formulas if you like. I just think this is a little bit easier of approach. The next one's going to be the same thing. As far as the vertex goes, we have 0, 0. In this case, though, my 4p is equal to -4. So now we're going to have a negative p. All right, and that's perfectly fine. I don't know why I'm dividing by -4, maybe because I said it. And we also know that my y is squared in this case. So since my y is squared, that means my graph is going to open up to the right or left. Since p is negative, the next thing we need to identify is going to be our focus. So again, since p is negative, that means we're going to be moving to the left one. So our focus is going to be this way. If my vertex is at 0, 0, and I'm moving to the left one, that means my focus is going to be -1. So focus is going to be -1, 0. And then my directrix is going to be to the right one. And again, that's a vertical line. So that's going to be x equals +1. And again, they didn't need to sketch the graph, but I think just sketching this graph, I think makes everything a lot more sense. So on to the next one. You can see that in this case, we have our x and our y are not on the same, are on the same side. We need them to be on opposite sides. So the first thing I'm going to do is I'm going to subtract a 6y on both sides. Therefore, I'll obtain an x squared equals a -6y. All right. Now, again, you can see that my vertex is again at 0, 0, but my 4p is now not as nice. 4p is going to equal a -6. But again, I'll still follow the same process. I'll divide by 4 on both sides, and p is going to equal a -3/2. All right. Now, the next thing we're going to need to do is, again, like plot this information. I recognize that my x is squared, so I know my graph opens up or down. But since p is negative, I know it's going to be opening down. So I'm just going to plot this graph. All right. And I know it's going to open down. Now, again, if my vertex here is at 0, 0, right, because I'm not adding or subtracting anything from the x or the y, there's no h or k. If I need to go down from my vertex a -3/2, right, because it's basically my vertex plus a -3/2, that's going to be the y coordinates. So I can say my focus here is 0, -3/2, and the directrix is going to be minus a negative, so that's going to be up. And again, that's a horizontal line, so that'll be y equals a +3/2. All right, into the next equation. Again, same kind of idea. We're going to want to get the, x's and y's on opposite sides. So the first thing we're going to do is add a 4x to both sides. Then I have a 3y squared equals a 4x. However, remember that we do not have anything with coefficients for the quadratic expression. So I'm going to divide by a 3 on both sides. That'll give me a y squared equals a 4/3 x. So again, nice thing is we know our vertex is again at 0, 0. We know that we see that y squared, so we know my parabola opens up to the left or to the right. But since my p is going to be positive, I know it's going to open up to the right. All right, so again, I just like to kind of do a quick little sketch here. All right, so it's going to open up to the right. Well, how far is it going to open up to the right? So 4p in this case is equal to 4/3. So I'm going to divide by 4. But remember, dividing by 4 is the same thing as multiplying by the reciprocal, which would be 1/4. So therefore, you can see my p is going to be 1/3. So if I'm going to add 1/3 and I'm going to go to the right, my new focus here is going to be at 1/3, 0, right? Because I'm going to need to add 1/3 to the x coordinate. And then my directrix then is going to be a vertical line 1/3 to the left of my vertex. So that would be x equals a -1/3. So hopefully you can kind of see, even though these have some fractions, again, just understanding the orientation of the parabola, and you can easily kind of just work your way through adding and subtracting and to identify the focus and the directrix. All right, so now we're going to work on just a couple more problems where we do not have where the vertex is not going to be at the origin. So you can see here now I am adding and subtracting to my x and my y. Again, for this case, kind of like the problem I did, we could easily just kind of rewrite this as x minus 0. You don't need to, but sometimes it's just helpful for students to see that. Now, one of the main issues that students have, or one of the problems that a lot of them will do, is they'll confuse the h and the k. Remember, h is always with x, k is always with y. So in this case, my vertex is going to be 0, 1. Make sure you remember that. And again, I'm going to plot that. So 0, 1 is going to be up 1, and that will be my vertex. Now, I see my y is squared. So therefore, my parabola is going to open up to the left or to the right, and I see my p, whatever it is going to be negative. So therefore, I know my parabola is going to open up to the left. Okay, and that's going to be very important because I don't like following those formulas I gave in the notes. I like to just visualize. Based on this information, I know my parabola has a vertex of 0, 1, rather simple, and it's going to open up to the left. Now what I need to do is identify my p. So I have my 4p is equal to -8. Divide by 4 on both sides. P is equal to -2. You could probably have done that in your head. But it's okay. So if I have my vertex at 0, 1 and I'm moving it to the left 2, I can now say my focus is going to be -2, 1. And my directrix is going to be a vertical line, right? 2 units to the right of that vertex. So that's going to be x equals a +2, right? Or, it'd be 0 minus a -2, which would give you a +2. In next equation, you can see that this is my h and this is my k, but notice how they're positives, right? So again, like x minus -3 quantity squared equals 12 times y minus a -1. Students still get confused with that as far as identifying the h and the k. They want to take h as -1. But again, if you can see, the formula, remember, is x minus h, y minus k. So you have your h and your k in that regard. And so when you have the positive, it's really minus a negative. So my vertex, again, my h is with x, my k is with y. In this case, it's going to be a -3, -1. All right. So I'm going to go ahead and plot that just real quick to kind of get an idea. So -1, 2, 3, -1. All right, and now what we're going to do is, I see it's an x squared, so therefore I know it's going to go open up or down. But since my p I know is going to be positive, right? So 12 equals 4p. We could just say p is equal to 3. So therefore it's going to be up. So I know my parabola is going to open up. And again, if I was trying to identify this, now here's where the formulas probably be helpful, right? You could easily count 3 units over. Hopefully you recognize that the x coordinate's not changing. Like if I'm just trying to find this focus, I'm just going up, right? So my focus is going to keep that x coordinate the same, but now it's going to be -1 plus 3. So if I just take -3 and if I just move it up 2 units here, you can see that's going to be a +2. As far as my directrix, it's going to be the exact same thing. I have this value of -1. So I'm going to have my directrix, I'll just write that. So it's going to be x equals -1, but it's going to be minus my value p, which is 3. Okay, so it's always been, it's going to be a y coordinate now minus that. So x equals -1 minus 3 is going to equal a -4. 1, 2, 3, 4, which again would make sense here, right? And again, that's going to be not an x, that is a y. Oh, see, you can see me making these mistakes. Jeez, slow down. Okay, so that's basically the idea when you have something in standard form. But typically students, once they kind of get the practice of that, they're like, all right, I feel kind of comfortable with that material. What else do you got? And that's where we bring into completing the square. And that's where a lot of students are like, oh man, we spent all that time and now I got to go back and remember all of that completing the square stuff. So really the only difference with these problems, guys, is you're just going to have to complete the square first and then work to it. I think I gave 4 problems just because students still just need more practice with this. So what I'm going to do is just do these completing the square. Do these have coefficients? No, they don't. So, all right. Is that the same? No, it's not. Okay. So what I'll do is I'm just going to kind of work through these rather kind of quickly. I'm not going to go through the completing the square process just because we have already done that kind of extensively in this class or in last chapter at least. So first thing I'm going to do is I'm going to separate the x's and the y's to get them on opposite sides. And then I'm going to complete the square here. Hopefully you recognize to complete the square, I'm going to want to add a 1. Or you could take the b divided by 2 and square it. -2 divided by 2 is -1. Negative squared is 1. But remember, if you add a 1 to the left-hand side, you need to add a 1 to the right-hand side. Now this goes, and now I can factor that down into a binomial squared. Oops, that's supposed to be a 1, which is what we were looking for. And then over here, we have a 4y minus 8. Now, one of the reasons I wanted to do this, or I wanted to kind of cover these problems, is we don't want to write our identify our vertex in this case. If you look at the formulas, it's 4p times y minus k. So in this case, what I'm going to want to do here is do x minus 1 quantity squared. I need to factor out the 4. And that is the big step that students miss, is that factoring out the 4. Okay, because again, look at the formulas that we did, right? It is all the way up here, all the way up here. It's 4p times x minus h, or it's going to be 4p times y minus k. So you got to make sure you factor out. You got to make sure that coefficients of your x or your y's is going to be 1. And then you can go ahead and apply the same kind of techniques that we did before here. In this case, we know that my x is squared, so it's going to open up or down. We know my p is going to be positive, so it's going to open up. And now I'm just going to kind of quickly do this as long as the numbers work out. So my vertex is 1, 2. My value of p is going to equal 1. Since I know that it's going to open up, my new vertex is going to have, I'm going to add 1 to the y coordinate. So that's going to be 1, 3. And my directrix is again going to be a horizontal line, right? So that's going to be y equals 1. Because so basically I'm just going to take 2 and then I'm going to subtract 1 from it. And again, this is something that we have covered extensively now. So this is something that I do. I'd have the students go up to the board and do this. So that's why I'm kind of running through these problems a little bit quicker. Same thing. First thing I'm going to do is separate the x's and the y's. So therefore this will be a negative 8y minus 1. Now I'm going to complete the square. Again, to complete the square of the middle term of 6, you could do your b divided by 2 squared, or hopefully you recognize at this point that I'm going to want to add a 9 to both sides. So in this case, I have a negative 8y minus 1 plus 9. That can now be simplified to an x plus 3 quantity squared. And then here, you're going to have a negative 8y, plus 8. So again, factor out that negative 8, right? So when we do that, we get a negative 8 times a y plus 1. All right. Now, again, you can see that my x is squared, which is fine. So therefore, my vertex is a negative 3, negative 1. And my p is going to equal negative 2. So that tells me now my graph is going to be opening down, right? So if I have my vertex here, and again, sometimes it's just helpful, like again, to plot it, negative 1, 2, 3, negative 1. So there is my vertex. So my focus is going to be going down 2 units. And sometimes just by graphing it, you can identify like what the new focus is. But all I'm going to do is just add negative 2 to negative 1. So therefore, it's going to be negative 2 minus 1, right? You're adding p. If you look at the formulas, I didn't do it over in this case. But if you add p to your y coordinate, that's going to move it down. So that's going to take us to a negative 3, negative 3, which again makes sense here into the context of my graph. And then for my directrix, again, this is going to be a vertical line. That's going to be x equals a negative 1 minus a negative 2. And you can see in that case, 1, 2, that's going to give me this line here, which is going to equal a positive 1. Okay, so our x equals a positive 1. All right, now we just have 2 problems that we're completing the square with y's, which again, guys, is not really going to make much of a difference. You're going to follow the same technique. The only difference here is we know that the x and y coordinates open up to the left and to the right. So I'll have a y squared plus 8y equals 4x. Complete the square when my middle term is 8. So you could do 8 divided by 2, which is 4. 4 squared is 16. Or hopefully you already recognize that would be 8y plus 16. And again, just make sure you subtract or add a 16 to both sides, right? Because you got to keep that equation true. Now I can factor this out. So this becomes a y plus 4 quantity squared, and I can factor out a 4 here. So that becomes an x plus 4. Okay, so now we can identify my vertex. Remember, everything's switched. X is with H, Y is with K. In this one, it doesn't really matter because they're both the same, but just kind of be careful with that. And then my P is going to be 1, right? 4P equals 4, so therefore P is equal to 1. Since P is positive and my Y is squared, I know the graph is going to open up to the right. So I'm just going to go ahead and sketch this. 1, 2, 3, 4, 1, 2, 3, 4. Okay, and I know it's going to open up to the right. However, just kind of going with the idea here is if I'm moving this focus to the right, make sure that you add that 1 to the x coordinate, right? The y coordinate is going to remain the same, but the x coordinate is now going to be a negative 3, negative 4, which makes sense, right? You'd have a negative 3, negative 4. But again, you could easily just do that in your head. You don't really need to show this. So I'm just showing this work at least one time and then I'll do the other one quicker. The directrix then is going to be that same thing. It's going to be a vertical line though. So that's going to be x equals a -4 minus 1, right? Because you're subtracting p. So in this case, -4 minus 1 is equal to a -5. So x equals a -5, which again, makes sense, right? You're going to have that value to the right or to the left of your vertex. All right, last one. Let's go ahead and just, again, separate. So minus 2y equals a -8x minus 1. Again, you're going to want to factor out that 8. But before we do that, though, let's complete the square, right? Because I'm like, that's not going to be fun to factor that out. So if I go ahead and complete the square here, that's going to be a +1. So therefore, in this case, if I have -8x minus 1 plus 1, you can see that, oh, I don't have to factor this out. This can be factored down into a y minus 1 quantity squared equals a -8x. Now, again, remember that you could also rewrite this as a y minus 1 quantity squared equals a -8 times x minus 0. It's just sometimes important to remember your vertex here is 0, 1, right? H is always with x, k is always with y. So now in this case, we have your vertex as 0, 1. We can see that p is going to be a -2, right? -8 equals 4p, divide by 4 on both sides, p equals -2. Let's just go and sketch a graph here. Since y is squared, we know it opens up left to right. Since p is negative, we know it's going to open up to the left. So we'll do 0, 1, okay, and p is -2. So we know our graph is going to look something like that. And even just by sketching it right here, you can see that, oh, I already kind of found the vertex. But again, like you're going to add a -2 to the x coordinate here, which is kind of simple. That's -2, 1, which is obvious also from the graph. And then you're going to subtract the -2 or just go to the right to find the directrix. Just remember it's a vertical line. So it's going to be x equals a +2. All right. So that's basically identifying the vertex, focus, and the directrix. But what about if I gave you the vertex, focus, and the directrix and asked you to write the equation? Now, the one thing that I think is the constant throughout this whole chapter is plotting the information. Whenever you're writing the equation, plot the information. This is one of the first things that we want to do when we're trying to understand writing the equation. I'm not going to scroll all the way back up, but even that first problem, we understand we have a vertex. Okay, what do we know about a vertex? We can represent that as h and k. Oh, we have a coordinate point. How can we represent that? We can represent that as an x and y. So if you're given the vertex and the focus, plot those points on the graph. Because remember, one thing that we know that the vertex always opens up towards the focus. We know that the directrix is always perpendicular to the axis of symmetry. So in this case, we're given the vertex and the focus. I plot the vertex, I plot the focus. Just by that information alone, I'm able to determine that the vertex has to open down and that p is going to be negative, right? It's going to open down. I mean, it's going to be a vertical and it's going to be a p is going to be negative. Since it's vertical, I'm going to use this equation. And remember, p is the distance from the vertex to my focus. Well, since we're going down, it's going to be a -2. So then all we do is we plug in our coordinates for our vertex, which in this case is hk. So it's going to be 0 and 0. And then we plug in -2 in for p. And therefore, you can see we get an x squared equals -8y. Now, next equation, we have our focus is 3, 4, and our directrix is y equals 2. Again, so I plot the focus here. And I plot the directrix, which is at y equals 2, which is incorrect because I think that was supposed to be, hold on a second. I think that was supposed to be x equals, actually, I did not do y equals 0. Directrix, x equals -2, x equals -2, y. Yeah, jeez, I can't believe I did this problem wrong. Crazy me. All right, so let's go and do another problem here because I did this wrong. That's a vertical directrix, right? Vertical directrix is not correct. If your directrix is y equals 2, that's a horizontal line. So my formula is all wrong. Jeez. Guess I get to highlight me making a mistake in front of you guys, but that's okay. Because that's part of the slowing down process, right? And that's why I think it's so helpful to sketch the graph so you can visually see what's going on. So here's my focus, here's my directrix. Now, the important thing is you can understand that the distance okay? If here's my directrix, here's my focus. So I know that my vertex, which we need to identify, is going to be over 2. My problem is we just need to be able to figure out, like, what is the distance between my vertex and my directrix? So the problem is, if we have 3, 4, so we're up 3. So let's do this. Did I do this? 1? Okay. So 1, 2, 3, and then 4. 1, 2, 3, 4. Right? And my directrix is at y equals 2. Oh, I wrote that. Oh, man. All right. So let's just kind of go through this idea here. So, I've messed up this problem all the way. All right. So I plotted my focus and a directrix. Now, again, what is something that we know about our vertex and directrix? And let's actually go to this equation right here. This isn't something we've talked about yet. If you look at the focus and the vertex and the directrix, you understand that to go from the vertex, to the focus, that's P. And then to go from the vertex to the directrix, that's opposite of P, right? You add P, subtract P. So therefore, the vertex is directly in between the focus and the directrix, right? So if I have my directrix and I have my focus, then my vertex is going to be right in the middle between them. So if I have a focus at 3, 4 and a directrix at 2, I know it has to be over, like the vertex and the focus are going to lie in the same line of symmetry. But my vertex here is basically going to be at 3, 3. It's going to be right in between. So 1, 2, 3, and just go 1, 2, 3. It's going to be right in between the vertex and the focus because the distance from my vertex to my focus is +1. The distance from my vertex to my directrix is going to be, -1 in the opposite direction or going down 1. So I don't know what I was thinking when I was doing this problem earlier, but now I have my vertex and I can say the distance from my vertex to my focus is 1, but it's going up. So therefore P is going to be a +1. This again is another vertical parabola. So that's going to be X, let's see, -h. So I'm going to use the same equation equals 4P times Y minus K. Okay. So now I'll just plug in my vertex, which is going to be a X minus 3 quantity squared equals 4 times 1 times Y minus 3. So I have a final answer of X minus 3 quantity squared times 4 times Y minus 3. Okay. So now what I did is I just kind of gave the students last 4 problems, again, that they would work on in their groups, and then they'd go ahead and present those on the board. So let's go and take a look at the problems that my students would have had to work on and doing the same thing. It's just writing the equation of the parabola in our standard form. Oh, and one thing actually, before I get into this, if you remember, we did, if you remember at the beginning, the first problem we did was writing it actually in standard form, okay, or what we call our general form. In this case, we could do that exact same thing here. The only thing we'd need to do is we just need to expand this and then get all of our values on the same side. So that's just another thing I just wanted to recognize. I don't spend the time with my students doing that. But it is something that I want to make sure that they're aware of. If they need to identify it in general form, they would just expand it and then get all the terms to the same side. All right. So again, first thing we're going to want to do is plot the points. So my vertex is 0, 5, 1, 2, 3, 4, 5. And my focus is at -1, 2. That's not supposed to be. That's going to be -2. Oh, jeez. How did I not check that out? Let's skip it and we'll come back to that one. Because there's a typo there and I don't know if it was supposed to be a 2 or a 5. But if that's supposed to be -2, let's just do -2, 5. And I'll come back and fix that. So if this is going to be a -1, 5, there's my focus. Okay, so now you can see that my vertex is going to be opening these up horizontally. And since we're going to the left, P needs to be negative. All right, so my formula here is Y minus K quantity squared equals 4P times X minus H. So again, this is my H and this is my K, right? And the distance here from my vertex to my focus is 1. But again, since it's going to the left, it's going to be in negative. So this would be Y minus K. So that's going to be Y minus 5 quantity squared equals 4 times -1 times X minus 0. So therefore I'd have Y minus 5 quantity squared equals a -4 x. Next equation, y is equal to 0. Next equation, we're going to have, again, another vertex at 0, 5. 1, 2, 3, 4, 5. But in this case, my directrix is at 0, or y equals 0. Okay, so there's my vertex, and there's my directrix. That means my focus now is going to be, or again, remember the distance from the vertex to the directrix is opposite of P, right? So therefore, my focus is going to be up here. Well, how far should it be? Well, again, the distance from the vertex to the directrix is the same as the distance from the vertex to the focus. It's just in opposite directions. So this is going to be my H and my K. This is going to be my focus, which is going to be equal to 5, right? So my P is going to equal 5 in this case. Again, this is a vertical parabola. So using the formula, x minus h, quantity squared, is equal to 4p times y minus k. Again, not sure why I used the same h and k in this case, but I did. So we'll do x. So we'll do x minus 0, quantity squared, equals a 4 times 5 times a y minus 5. And again, like one thing I always want you to like remember, you can always go back and like check your work. Right? Like, all right, here's my vertex parabola. Like that's what I graphed. I should have a x should be squared, right? And my p should be positive. Yes. Here my parabola is opening up to the left. So therefore y should be squared and my p should be negative, which again, you can see is going to be correct. The next one again is my focus and my directrix. So in this case, again, just plot the information. So we have 1, 2, 3. And then we have a directrix at x equals negative 3. 1, 2, 3. So that's my focus. Now, how should we understand the orientation? Well, remember, if the directrix is a couple things to keep in mind. First of all, so the directrix, remember, is perpendicular to the axis of symmetry. Also, the focus and the vertex lie on the same axis of symmetry. So the line of symmetry needs to go through the focus. And that's not one thing I've talked about before, which is important for us to understand though. The line of symmetry, the vertex and the focus go through the line of symmetry. And remember, that's perpendicular to the directrix. So if I know my line of symmetry or my axis symmetry is horizontal, that means my parabola is going to open up, right? And it always opens up towards the focus. So therefore, I know it's going to be a horizontal parabola. So immediately, I'm just going to write down the general formula. Oops, x minus h. Okay, so I know it has to be a horizontal. Now, the next thing, again, is I need to figure out the vertex. Well, again, what I can do is the distance from the directrix to the focus is 2p, right? Because remember, the distance from the vertex to the focus is p, and then distance from the vertex to directrix is opposite of p. So if I just figured out this distance, which ends up being 6, you could count or you could just look at these values, then you could just say, all right, p is equal to 3. That means the distance from my vertex to my focus is 3. So where should this midpoint be? And again, if you have some problems, if you have a problem where, where it's not at the origin, if you remember what we did in our what you need to know section, you could find the midpoint of your kind of like those 2 points or find that middle point there. Just important to understand that they're going to lie on that axis of symmetry. So in this case, though, we can see my vertex is going to be right there because it has to lie on that same axis of symmetry. And again, that makes sense here. So my origin or my vertex is going to be at 0, 0. All right, so in this case, I'm going to have y minus 0, quantity squared, equals 4 times 3 times x minus 0. So we'll have y squared equals 12 times x. All right, and then the last problem, ladies and gentlemen, is again going to be a problem where we have the vertex is at 0, 0, and then we have a directrix at x equals negative 2. And did I really want a directrix at negative 2? No. Let's do x squared, y squared negative. Oh, I guess that's probably what I did want. Let's see, let's change this up here. So here we're going positive positive. Here we're going positive, positive, to the left, to the left. So I'm going to want to have a problem that's going down. So let's just actually make this y equals 2. So I'll go ahead and change that into my notes. But looks like when I changed that first problem, that kind of messed everything up here. So if I want y to equal positive 2, now that will be my first parabola that's going to open down. So I'll have y equals 2, which is going to look like this. This will be my vertex. And again, we have vertex to the directrix. Now again, that's going to be a positive 2, right? So the important thing is I know that my focus then needs to be somewhere down here. Well, if my distance from my vertex to my focus is 2, that means the distance from my vertex to my, the distance to my vertex to my directrix is positive 2. That means the distance from my vertex to my directrix is going to be a negative 2. So I'm going to go down 2 units in this case. That's going to be my focus. So again, I know my parabola is going to open down. So I'm going to use the formula x minus h squared equals 4p times y minus k. And this is why it's kind of important that I like to go through these problems in my class first. So therefore I kind of get out all those little wrinkles. My vertex is going to be at 0, 0. And in this case, we can see p, since it's going is 2, but since it's going down, it's going to be a negative 2. So therefore I'll have a x minus 0, y squared equals 4 times a negative 2 times y minus 0. So I have an x squared equals negative 8 times y. And there you go, ladies and gentlemen. That is basically it as far as our process. So if you have any kind of questions or some understandings, make sure you go ahead and add them down below. But really just kind of recap, when you're given information, plot it and identify the vertex and the value of p. And remember, p is the distance from our vertex to our focus. It's our focal length, and it can be positive or negative depending on the directions. And then as well, if you need to identify all those pieces of information, if you have it in general form, go ahead and complete the square to write it in standard form. And if you have it in standard form, just make sure you understand the formulas for your x, your h, your k, and your p. And then you can go from there. So there you go, ladies and gentlemen. That is everything regarding our parabola. And I'll look forward to seeing you on the next video. Cheers.